right, let's pick up our task review for Chapter 8 with questions 3 and 4. This one's going to be a bit longer because this problem is a bit longer. The first thing that I need to notice here is what I'm being asked to do. So in this problem, I'm told to graph the following functions and then identify the given characteristics. So we're going to have to start by graphing, but before we do that, we're actually going to have to fill out this table right here. So let's take a look at what we've got. The first thing that I notice about my equation is that it's in standard form. And so in order to find the vertex of something that's in standard form, there's a special equation we have to use. We have to use the equation x is equal to negative b over 2a. Okay? So negative b over 2a. If I look at my equation up here, I can notice that a, the thing in front of my x squared, is negative 1. B is positive 6, and C is negative 4. Okay, so now I can come back down here to plug my numbers into the equation. The opposite of 6, so that's going to give me negative times 6, over 2 times negative 1, which is negative 6, over negative 2, which is 3. What this means is that the x-coordinate of my vertex is 3. Now I'm not done yet, obviously, because I'm going to need to figure out what y is, what my other point is, and to do that, I just plug it back into my original function. So this up here, okay, and let me erase that. Keep this a little tidy. So if I go back to this, I'm basically just going to rewrite my function, but replace all of the x's with a 3. So I'm going to have negative 3 squared plus 6 times 3 minus 4. And I need to simplify this. I can do this in my head, but you also are just welcome to type this into your calculator to get the output. It's usually a little bit faster. This is going to give me negative 9 plus 18 minus 4, which C is going to give me 9 minus 4, which is 5. So y is equal to 5. So I go back here. I know my vertex is at the point 3, 5. Now remember, the vertex is the point on my parabola where it's symmetrical. So if I go back to my table right here, and let me choose a different color, the center of my table is going to be where the vertex goes. So I know that this is 3, 5. Okay. Now that's important because to get the rest of my inputs for the x column, I'm going to have to count up and down from 3. So I can go 3, 2, 1, 4, and then 5. And so you have to center your graph around that vertex right there. Okay, now we do the same thing to get my outputs. I'm going to input, or I'm basically just going to do the same thing we did down here, but you're going to change what you replace in the function. So instead of plugging in 3, we would plug in 2, and then solve from there. If I go and plug those back into my calculator, I should get 1, 4, 4, 1, and those will be my data points. Notice that there's symmetry on the y column. If there's not symmetry, you've done something wrong. The last thing we need to do is graph this. So I'm going to graph my points. Let's see, 1, 1 is going to go right here. 2 over 2 up 4. Over 3 up 5. 4, and then 1. And then I just sketch my parabola. Notice that my vertex, that 3, 5, is at the top. So that means it's going to be a maximum. And it's the value of the maximum is going to be at, there's 2 ways you could write it. You could either just rewrite the vertex as a point, or you could say like the max value of y is going to be 5. Both kind of refer to the same thing. And then your axis of symmetry is going to be the x equation. Remember, it's going to be x equals whatever your x coordinate is of the vertex, which is 3. And we're done with question number 3. Pause the video, and I'm going to move on to question number 4 when you're ready. All right, let's take a look at question number 4. Number 4 is a little bit easier in the fact that this question is in vertex form. So if I look at my equation, notice it's in parentheses. That's a good indicator that it's in vertex form. Recall that vertex form is when I have a times x minus h squared plus k, which I can see the pattern between those two already. Now, why is vertex form helpful? Because it actually gives me the vertex, right? It gives me my center point of the graph. The vertex is going to be the opposite of the number inside the parentheses, comma, the one on the outside. So the vertex is always hk. So in this case, it's going to be -3, -2. Again, you have to be really careful that you take the opposite of this number. We take the opposite because of that minus sign in the original function. So if my vertex is at -3, -2, I can count up and down just like what we did before. I know that this is going to be -2, -1, -4, and -5. Just like before, I'm going to have to plug those numbers back into my original function. You can do that on your calculator. And if we do that, we're going to get 14, 2, 2, 14. We get some nice symmetry. I won't be able to graph these 2 points, the 14s, but I can graph everything else. -2, 2 is right there. -3, -2, -4, +2. And then I can kind of estimate that the 14s would be somewhere up here, although those aren't going to be perfect because I'm estimating. Sketch your parabola, presto changeo, we're done. The domain of this is going to be the same as it is for all the parabolas we've been looking at so far. X equals all real numbers. And then the range is going to be everything that's bigger than -2. So y is everything that's greater than or equal to -2. The last thing we need to do is talk about the transformations from the parent function, which remember the parent function is this thing right here. And we can do that just by looking back at our original equation. Okay, so if I look back here, my a is 4, and since that's bigger than 1, I know that this is going to be a vertical stretch. Because remember, when a is bigger than 1, it's a stretch. When a is between 0 and 1, so like when it's a decimal or a fraction that's less than 1, it's called a squeeze. Or compressions or shrink, they all mean the same thing. And then when a is less than 1, so when it's negative, it's going to reflect the graph over the x-axis. So since a is bigger than 1, it's a stretch. I also can look at my vertex right here. That's going to tell me if I had any horizontal or vertical translations. If I were to graph -3, -2, I would have to go 3 to the left. So it's 3 to the left. And then for my vertical translation, I went down 2. So I did have 3 transformations here. This one did not reflect because it wasn't negative, but it can happen sometimes. All right, that is the end of this video. Sorry it was a bit longer.